Okay, so this video is for pages 109 through 111, and we're talking about zeros of a polynomial. So first thing is the fundamental theorem of algebra that says if fx is a polynomial of degree n, where n is greater than 0, then f the polynomial has at least one zero in the complex number system. Pretty much what that means is that you have degree n of some polynomial, and for every degree n you have to account for the zeros in which you have. And then there's the linear factorization theorem, which says if fx is a polynomial of degree n and n is bigger than 0, then f, the polynomial, has precisely n linear factors, meaning you need to account for every degree of the polynomial as a linear factor. And the last thing that we're talking about is the rational zero test. And what the rational zero test says is the following. So if you take your polynomial and you put it in order, this first a sub n thing is your leading coefficient, and the very last coefficient or term is a sub 0. The factors that make up a sub n we're going to call our q's, and a sub 0 is going to make up our p's. So what we're going to do is we're going to make a list of rational zeros that consists of p's over q's, and it says right here, in case you forget, p is the factors of the constant and q is the factors of the leading coefficient. And this is the key word right here. This is only going to make up a list of possible zeros. They're not all going to work, but it's going to give us a place to start with. So we're just going to do a little bit of review first before we try the first problem. So the first problem says a polynomial has a root of 5 with a multiplicity of 3. It also has zeros of 1/2, -3, and 9, all of which have a multiplicity of 1. The scale factor is -2. How many zeros does the polynomial have? In other words, we're asking what the degree is. So this polynomial with root 5 counts 3 times. 1/2 counts once because it's a multiplicity of 1. -3 counts once because it's a multiplicity of 1. And 9 counts once because it has a multiplicity of 1. So this polynomial, when you add up 3 plus 1 plus 1 plus 1, it's going to be 6. So it's going to be a 6-degree polynomial, which means it has a degree of 6. Okay, so now let's apply what we were talking about. So down here it says find the rational zeros. So what we're going to do is, if you were to look at this and try to factor, this isn't going to factor and come out to anything that's useful for us. So what we're going to do is we're going to do our rational zero test, and we're going to make a list of our p's. Yep, sorry. We're going to make a list of our p's over our q's. So remember, p comes from the constant term, and we're going to list the factors of the constant term. So I have plus or minus 24, plus or minus 12, plus or minus 8, plus or minus 6, plus or minus 4, plus or minus 3, plus and minus 2, plus and minus 1. And then q's come from my leading coefficient, which is a 1, which is just plus or minus 1. So now what you're going to do is you're going to actually do p divided by q. And this is nice because q down here is 1. So we have this really long list of all these zeros that could work. Okay, so we're going to smart kid cheat. What we're going to do is we're going to grab our calculator, and we're going to throw our polynomial into a graph. So all I'm going to do is graph this. So I'm going to graph x to the 4th minus 6x to the 3rd minus 8x squared. Oh, sorry, 8x. Oh, I typed that wrong. It's 6x squared, 8x, and then plus 24. So just double check that you have x to the 4th minus 6x squared minus 8x plus 24. and your polynomial should look something like that. And so here's what we're going to do. We're going to smart kid cheat, and we're going to guess that 2 is going to work. If you go to this list, plus or minus 2, or just positive 2 divided by positive 1 would get me my 2. So I'm going to put 2 in my house. And this is where we get away with the smart kid cheating, because we're going to mathematically prove this works. So in theory, here's what's happening is these are all the lists of the possible zeros you could have. So you could go through and test every single one with synthetic division until you found the one that worked. But instead of doing that, we've used our calculator, and we know that 2 works, but now we have to go to our paper and show that it works. So to show that it works, we're going to do synthetic division. Oh, and I made the boo-boo that you're all going to make. I forgot to add that 0 in right there for the x cubed term. So let me just wipe this out really quick. So I dropped on my 1. And because we get a remainder of 0, we know that 2 worked. Well, we can smart kid cheat even further, and we know, because if you look right here, we know that it bounces off of that point. So 2 should actually count at least twice because it bounces off. So I'm going to put 2 in the house again. And I'm going to do synthetic division again with my new numbers. So I'm going to drop down my 1. And so now, because I know that it worked twice, now I'm left with an x squared plus 4x plus 6. And I need to factor that. And 6 only has factors of 1 and 6 and 2 and 3, none of which are going to make 4. So this you're going to have to use the quadratic formula for. So x equals the opposite of b plus or minus the square root of b squared minus 4 times 1 times 6 all over 2a. So x equals negative 4 plus or minus the square root of 16 minus 24. And now we have to clean this up. So negative 4 plus or minus this right here, we pull out the I, square root of 4 and square root of 2. So 2i square root of 2 all over 2. And then reduce this all down. Everything gets divided by 2, so negative 2 plus or minus I root 2. And that makes complete sense because if you think about it and go back to your graph, if I can get it to show up for you. That 0 that we had right there was the only 0 we had. So the other 2 zeros have to be imaginary. So 2 counts twice. So 1, 2, 3, 4 zeros, fourth degree polynomial. So now you know that the zeros are x equals 2, and it counts twice, comma, negative 2, plus and minus I root 2, which counts as the other 2. So there is all of your zeros. So go back to Edmodo and there'll be a video that will help you do the next page.